two cones are shown. The heights and bases of cone 1 and cone 2 are congruent. In cone 1, the vertex is directly above the center of the circle. In cone 2, the vertex is directly above a point on the circle. So far we know cone 1 and cone 2 have the same height because it says the heights are congruent, and we know they have the same base because it says the bases are congruent. Now in cone 1, our vertex, which is this point right here, is directly above the center of the circle. And in cone 2, the vertex, which is this point right here, is directly above a point on the circle. Now the circle is the base for both cone 1 and cone 2. So we know that circle is the same size in each cone. Now we want to select the phrases that correctly complete the sentences comparing the cross sections and volumes of cone 1 and cone 2. So the first statement here is about the cross sections. So it says the area of a cross section parallel to the base at the same height in each cone is. So if we're taking a cross section, remember when we have a 3D figure and we slice it, a cross section is the 2D shape that appears inside. So if we were to slice these cones parallel to the base, we would slice them horizontally like this. And when we sliced them, that cross section would be a circle because our base is a circle on each cone. Now, since we know that the bases of cone 1 and cone 2 are congruent, the area of a cross section parallel to the base at the same height in each cone would be equal for cone 1 and cone 2 because they have congruent bases. When we are talking about volume, the volume formula for a cone is right here. This is screenshotted right off your state test reference sheet. So the state test reference sheet gives you that the volume of a cone is equal to 1/3 times pi times the radius squared times the height. So remember, the radius is the distance from the center of the circle to the perimeter. So in each of these cones, since they have a congruent base, the radius would be the same in cone 1 as it is in cone 2. So we know for each cone, whatever number we substitute in the volume formula for radius, it's going to be the same as it is for cone 1 that it is for cone 2. Now, the problem tells us that the cones have congruent heights. So the height of cone 1 is equal to the height of cone 2. So if we're going to find the volume for cone 1 and the volume for cone 2, we would be substituting the same radius and the same height into each formula. So therefore, the volume of cone 1 is equal to the volume of cone 2.